So, you just picked up a Daly Smart BMS for your new lithium battery build, and now you're staring at a tangle of wires and a blinking Bluetooth dongle thinking, okay, now what? Well, don't sweat it. Welcome to This Explainer. Today, we're going to completely demystify the Daly Smart BMS setup process. We're going step by step through a foolproof guide that basically mimics your exact setup journey. We want to make sure your batteries are operating safely, efficiently, and doing exactly what you need them to do. Here is our roadmap for This Explainer. 1. Meet your Daly BMS. 2. Pairing your Bluetooth dongle. 3. Initial app preferences. 4. Voltage protection settings. 5. Current and capacity limits. And finally, 6. Balancing and temp controls. All right, let's just dive right in.
Section 1. Meet your Daly Smart BMS. If you're working with the M-Series Smart BMS, the ones ranging anywhere from 150 to 200 amps, you've got your hands on a seriously versatile piece of hardware. This system is engineered to handle lithium batteries across a massive variety of setups. Whether you're building out an off-grid RV, upgrading a golf cart, powering up a marine vessel, or even outfitting heavy-duty stuff like floor sweepers or forklifts, this BMS is your battery's brain. It's built to communicate and, most importantly, protect your investment in all those different environments. Section 2. Pairing your Bluetooth dongle. Okay, so the absolute first thing you're going to do is plug that Bluetooth dongle directly into the BMS. Simple enough, right? Next, grab your phone. Head over to the App Store if you're on an iPhone or Google Play for Android and download the Smart BMS app. Once you've got it open, you want to tap right on Local Monitoring. Almost instantly, you should see your specific dongle pop up on the screen. It usually has a name starting with the letters DL followed by some numbers, like DL4017. Just tap that dongle name, wait maybe 5 seconds, and boom, you're connected. But, tech is tech. What if it doesn't show up right away? Don't panic. Bypassing these common initial hurdles is exactly why we're walking through this. If you don't see the dongle, try hitting the series button on the app screen just to force it to recognize the device. Still nothing? Go ahead and physically press the little button right there on the Bluetooth dongle itself. If you're still stuck after trying that, the issue is probably physical. You'll need to go back and double-check all your connections, paying really close attention to those balance wires plugged into the back of the BMS. Section 3. Navigating initial app preferences. All right, assuming you're connected and ready to rock, you'll want to navigate down to Preferences and tap into the Protection Parameters screen. This is where the real work happens. Now, when you go to change your very first setting, the app is going to throw a password prompt at you. No need to go digging through a manual for this. The default Daly BMS password to unlock all these critical parameters is literally just 123456. Type that in, hit set, and you are officially in the driver's seat. Section 4. Core Voltage Protection Settings. Right out of the box, you've got to update these numbers to set up the absolute most crucial safety barriers for your lithium cells. Let's look at your cell volt high protect. The absolute physical max for LiFePO4 cells is 3.65 volts, but our source strongly recommends dialing this back a bit to 3.6 volts instead. Why do that? Well, the actual battery capacity you gained between 3.6 and 3.65 is practically zero. It's tiny. But stopping at 3.6 gives you a massive, massive safety buffer against overcharging. On the flip side, for your cell volt low protect, set that to 3.0 volts. That leaves roughly an 8% capacity buffer at the bottom, which pretty much guarantees you'll never completely kill your cells. Next up, you have to set the sum volt protect for the entire battery bank. Don't worry, it's just some simple math. If you've got a 12-volt system made of 4 cells, you just multiply 4 by your high protect of 3.6 volts. That gets you 14.4 volts. For the low protect, 4 cells times 3.0 volts equals exactly 12 volts. What if you're running a 24-volt system with 8 cells? Easy. Just 8 times 3.6 for a high of 28.8 volts, and 8 times 3.0 for a low of 24 volts. You just take those exact totals and type them straight into the app.
Section 5. Current and capacity limits. Now we actually have to tell the BMS how much power it's handling. The absolutely crucial thing here is understanding the difference between charging and discharging limits. Honestly, this is where a lot of folks get tripped up. Your charge over current protect needs to be set to exactly half of your BMS rating. So say you bought a 250 amp BMS, you'd set the charge protect to 125 amps. However, your discharge over current protect should be set to the full rating of the BMS, so the full 250 amps. They do 2 very distinct jobs, so keeping those separated is super important for safety. After that, scroll down to rated capacity. Now, the app is pretty smart. It automatically detects that you're using LiFePO4 cells, so you can skip changing the cell characteristics. But it isn't a mind reader. It doesn't know the exact size of your battery bank. You have to enter the actual amp-hour capacity of the specific cells you bought. Whether you're rocking a 202 amp-hour kit, a 230, or a massive 280, type that exact number right into the app, so the BMS knows the exact size of the fuel tank it's trying to manage. Section 6. Balancing and temperature controls. We're in the home stretch now, just making a few final performance tweaks. When you hit the balance open start volt setting, you're actually going to run into a bit of a debate in the battery building community. Some people argue that balancing should only happen at the very top of a charge, but expert guidance from our source suggests a slightly different and highly effective approach. They suggest setting the passive balancer to start at 3.0 volts. This basically ensures the BMS is constantly working to keep those cells perfectly matched whenever they get out of balance, instead of just waiting until the very last minute at the top of the charge cycle. Okay, let's rapid fire through these last essential safety checks. First up, change your sleep waiting time from whatever the default is to 65,135 seconds. Why? It basically stops the BMS from dropping into unwanted sleep modes. Next, leave your default protect right at 0.08 volts. If your cells somehow vary by more than that, the BMS will safely shut everything down. Finally, and I can't stress this enough, check your temperature settings. Set your low temp charge protect to 0 degrees Celsius. You should literally never charge a lithium battery in freezing conditions. Honestly, setting it to 1 or 2 degrees gives you a fantastic extra safety buffer, just to be absolutely sure. Before we completely wrap up, I've got one really fantastic pro tip for you: the first charge roll. When you first fire up the app, the state of charge, or SOC percentage, is honestly just a rough guide. To calibrate it perfectly, you need to charge your brand new system all the way up to full. So that's 14.4 volts for a 12-volt system. Once it hits that absolute maximum voltage, go directly into the app and manually change the SOC to 100%. From that point on, your battery percentage is going to read perfectly accurately. And there you have it. By following these structured parameters, you have completely demystified the Daly Smart BMS. You've successfully paired your dongle, bypassed the usual tech hurdles, established some ironclad voltage protections, and totally tuned your balancers. With all your safety buffers set and those initial preferences locked in with your handy 123456 password, the satisfaction of a perfectly dialed-in battery is officially yours. So my final question to you is, with everything locked and loaded, are you ready to safely power up your new rig? You've definitely got the knowledge to do it now. Thanks so much for hanging out with me on this explainer, and happy building.